We're about to start with ESnet Security Group Impact on Network Architecture by Scott Campbell from Lawrence Berkeley National Lab. Scott, take it away.
Hi, can you hear me? This being a Zoom,
Yes,
interaction, I have to ask the same questions, can I be heard and am I sharing the screen correctly? Let's see if I can find. All right, can everyone see that? All right, I will, excellent. Okay, so my name is Scott Campbell, and I'm gonna kind of give a fairly informal chat about what the security group did with regard to the ESnet 6 network architecture and kind of what we learned. And then I'm gonna just walk through some examples of what it is that we're doing. And then I'll probably run out of time. But if in the end there is time, I of course will answer whatever questions you might have. An overview of what it is that I'll be talking about is kind of some history, just a couple slides, and then the important part of the talk is, what is it that we learned, focusing on 4 general areas, what it is that we had to pay for it because nothing's free, and then some examples of our decision-making process and how it is that we implemented it or are implementing it now within the management network, and then time for questions. So the physical scope of the network is principally across the United States, though we have a number of transatlantic links to hook up to CERN as we do a huge amount of data transfer work. We connect all the DOE labs, bunch of experimental sites, supercomputers, a number of NSF facilities, instruments all over the world. We move all that data around ideally in a very performant manner. ESnet 6 that I mentioned before is our next generation network, which is a greenfield implementation, which means from the optical, we owned leased a whole bunch of optical fiber, and we implemented fiber infrastructure all the way up to the layer arbitrarily high on up for ESnet 6. So it's greenfield, all new, kind of fun. ESnet, who we are, this probably should have been the first slide, is we're just a high performance unclassified network. We do mostly science. We're through the Department of Energy Office of Science. We are run out of Lawrence Berkeley National Lab. We support research sites and whatnot. We also provide kind of generic internet connectivity for most of the DOE laboratories. And every 5 or 6 years, we update the core technologies behind the network. Usually that involves router replacement, investigating new ways of doing routing and data transfers and whatnot. And ESnet 6 is a complete, as I mentioned before, is a forklift upgrade of the physical and routing infrastructure. So the history and the reason why I'm here is for the first time, the security group was represented within the design process. So before then, it was just kind of, we happened to have a really good security culture at ESnet. So security wasn't ignored, but we as a group weren't represented. This wasn't personal, we're not terrible people, but it's just the group size. It wasn't really large enough. There wasn't a lot of experience. And it's, as I talk about later, there's a huge investment in time and effort to become involved in a project this size. And then as the third bullet point mentions, the security culture at ESnet is really awesome to begin with. So that's really a lot easier to work with. So getting to the point of this all, some observations and things that we learned while learning to play well with others. we as the security group, we're not as vertically siloed as everybody. We talk to everybody, we're responsible, for pretty much everything, the security of the organization at large. And so our communication patterns are different than other groups. And ultimately that was extremely useful. As part of the process, we have a lot more visibility. Visibility in the context of being exposed, being in the spotlight. So that was kind of interesting. We learned a lot about differences in the way that different groups approach problem solving, time management, and communication. I have a whole slide on that, and that was a really interesting learn. A really critical one is by being involved early in the design, and I have a, not surprising I have a slide on this too, is architecture and changes and ideas are built in from the ground up rather than being pulled into a meeting late in the game and saying, well, how do we secure this thing we already designed? So that was really nice. And it makes for a much smoother operation in terms of security not being a speed bump. And then the final observation is we are given, by being, kind of at the design table, you're given a much louder voice in getting your projects accepted, understood, and implemented. Nothing is, it's not punitive that something might not get put in place, but if you aren't advocating for it loudly, there's always something else that will take place. So the communication slide is that slide within my presentation that is kind of all over the place. So there it is. So communication, I bring up a couple of things that are like precursors to the what does it cost you slide. And it's just the more shareholders you have in the decision-making process, the more friction you have. And that's just like a human thing, right? And so you have to kind of overcome that reluctance to add people in, because security is, for many individuals, not a value add. They're not interested in security. They're interested in moving data. They're interested in network engineering. They're interested in writing really cool software. And so we have to think of a nice way of dealing with that. Because of our role in the organization, as I mentioned before, we talk to a lot of people, and we've learned that communication, it must be intentional. You can't just assume that people will understand what we have to say. It has to be regular. It has to be well thought out, and you have to assume that people just might not think about things in the same way that you will. So in the long run, rather than there being real technical issues as far as being integrated into the process, it involves strong communication and the ability to, as I say here, communicate well and genuinely listen to people's concerns. Which may sound kind of sarcastic, but it really isn't. And it's core to really getting things put in place. One of the most interesting things is exploring how the different groups go about problem solving. Because when your project involves a lot of work from the software development side and a lot of work from the network engineering side, you may, in the process of attempting to develop one document to share with both of them, realize that both groups have extraordinarily different ways of looking at problems, looking at solving problems, even communicating about problems. From the network engineering side, it tends to be ticket driven, some Jira, lots of small, fairly independent projects. They're driven, just in time fixes. This is broken, we need to make it go. Changes are made really slowly and really carefully. Nothing's done unless it's well understood, which is really important, because if they mess up, the network stops, and that's obviously not good for us. Software development, super Jira driven, lots of stand-ups, lots of development sprints. And so we needed to, when we have a requirements document, we need to address the needs of the group that we're asking to help us. And so ultimately we ended up writing kind of parallel documents that provided a way of communicating with the different groups in ways that they really could digest well. And that was until we came to that realization, it was kind of harrowing to try to get these documents written. So this is a big one, and it was quite surprising. The early design influence, as suggested before, if you aren't in there early, your engine will have a Pringles can in it, and it will be held in by duct tape. So you can effectively bake kind of like core ideas into the security design, but you got to be there early. And you know, like I said it before, and you'll hear it again, and you'll get sick of it. I inherited a tremendous security culture at ESnet, and so I didn't have to convince people that security was important. And another part of the conversation is every technology will have the same set of problems that you're trying to resolve as a security practitioner. You want to understand and try to adopt a clear, well-understood notion of authentication, logging, you know, so how do you keep people from doing things they're not supposed to? How do you know about stuff that's happening? How do you patch it? Who do you call when there's a problem? And all of that. And each layer within the network design answers all the same questions. And that was really helpful in understanding. And then when you aren't getting somewhere with someone, really, you have to stop and ask them, what problems are you trying to solve? And how is it that I can not stand in the way of that? And how can, you know, so how can we build a secure architecture that will let you do what you need to do at the end of the day? Because you don't want to create a situation where your users are working around you, because they will win and everyone will lose in the end. So new project acceptance. What I mean by that is the network engineers have a finite amount of time, and without an advocate for a project to be done, it just gets left behind. There's time to do 10 things, and there's a list 15 long, and if it's not part of core services, you need to strongly advocate for it, or it will just get left behind. And not because people don't think it's cool or interesting or fun or useful, but it's just not, there's just not enough time. So you can create a minimal impact by helping the architecture early, so you can kind of build security in rather than having to take time later and retrofit it. You can socialize your designs. So rather than showing up late and saying, you know, this is what I want to do, and everyone is shocked and hasn't thought about it, and there's natural pushback, you kind of socialize your designs. You're like, okay, this is what I'm thinking about doing. Is this a good idea? Will this break all the things? And so you can start from there. How much time do I have? Awesome. And then multiple groups. A lot of groups have the same problems and they don't even realize it, even though they're sitting in the same room and talking. So if you can find groups that have the same general sets of issues, you can try to architect solutions early that will make everybody super happy. And you can develop fun political capital that way as well, which will help project acceptance. And yeah, I found something on Twitter that totally supports me, so it has to be true. But it also really summarized that last slide nicely. And it just talks about the effort of pushing security initiatives is if you build it in early, it doesn't cost a lot in terms of human effort or having to argue with people or even, technical changes. And so that's the key to suffering less. Speaking of suffering, the costs, everything, nothing's free. Being invited to the party was not all fun and games. So security is part of every component, which is reflected in an immeasurable number of meetings, time requirements. There's a lot of talking, a lot of conversation, a lot of understanding that has to happen. And that just is a huge time requirement. And so you just have to be ready to accept that. And that was one of the reasons why we didn't do it before, is we didn't have enough staff to really cover the cost of that. Security is a checkbox on every layer. When there's a security problem, you will be dragged out and the spotlight will be put on you. So you have to understand each of the layers, not to the level of understanding that the experts have, but you have to be able to talk with them in the appropriate language and understand what it is that they're doing. And so there's a huge amount of learning. And then just pure project management overhead. For the first time, we have actual real live project managers, which is amazing. But even then, there's just a lot of keeping track of things that cost a lot, even more than the meetings. So inspirational thoughts is, this is another thing I'm going back on a lot is, just make sure you have the time and the resource budget for this undertaking. It is not tiny, but it is, it's totally worth it. It's a marathon endeavor. It's years long. So if you can't, you might not be able to run for a long time, but you have to kind of plan for this. Cultural change is hard. If you do not have a lovely security culture, you are going to have to convince people that they need to change, and that can be extraordinarily difficult. And a byproduct of that is the last bullet point, which is not the happy one, is that there probably will be pain. But that's okay, because in the end, it's totally worth it, but there will be times when you are not happy, and no one's happy. So now comes the kind of show and tell part. Some design elements of the management network. Just some of the pieces that we're putting together or have put together. And within ESnet 6, the things that we're building is basically a collection of services. And I'm just going to do a quick rundown of the things that we've defined as security services. And some of these I'm going to go into some detail in, and most of them I won't. The first one, which is the sinkhole service, is just a way of isolating the management network from the rest of the internet in a way that works with, so we're using routing to our favor. It's internal only, it's an active measure, it's a structural change. And then WAN network monitoring, which is a way of running the Zeek network analyzer / intrusion detection tool on our WAN links to begin exploring what that actually looks like and how is it that we can provide better services to our users. There are two services attached to kind of controlling traffic. They're internal and external, so we're trying to develop authenticated interfaces for users to control the traffic going to them a little bit easier. One is a flow spec traffic control service. So there'll be an interface that they can define 5 tuples to either block or to reroute or to throttle, as well as just kind of your classic BGP null routing, which is a really vanilla service, which says, you can provide a null route for an IP if it's in your routed space. Then there's 3 more services, which are kind of interesting and thus dynamic. The first is a filtered internet service, which is just kind of a way of structurally building in, there is no reason for you to transit 50 gig per second of NTP to a site. Like there's no healthy reason for it. And so if we build in a lot of a lot of classic DDoSes happen over a handful of protocols, which by their nature should not be as, gigantic flows. There shouldn't be a billion connections. So if we can architect that into the network, it will make it things a lot easier as far as addressing DDoS issues in the future. Obviously, we do prefix hijack monitoring. And then DDoS detection is just kind of volumetric attack detection. It's fairly straightforward. pretty much anybody who is an ISP at this point does that. And yeah, so those are the services. And that just kind of defines our interactions with our users, which are the various sites, laboratories. So what the management net is, it's just a command and control for all inter-router communications. So it's where the routers talk amongst themselves. It's where we SSH into the routers. It's where all internal ESnet traffic happens. It's isolated from the rest of the internet because really there's no reason not to. We use real addresses for everything. So we don't do RFC 1918 or anything on it. And we keep all of those real addresses in the global routing table because it makes hijacking a little bit more difficult. As suggested, no user or site data moves across the management net, so it tends to be fairly low bandwidth. And fortunately, there are not too many humans, which makes doing kind of behavioral analysis on it a whole lot easier. This is, for ESnet 6, we are working kind of on a US footprint-based approach for this version. Everywhere where there's a blue dot, we have a monitoring location for the management net itself. So this is not monitoring our users' data, but monitoring data on the management net itself. And basically every place where we have live optical gear, we have a Zeek instance, which is looking at the data there. And I'll kind of go into a little bit more detail into that later, but this just gives you a vague idea about the distribution of our efforts. And a really fun thing about the management net is it is all IPv6. There is a tiny bit of IPv4 that we couldn't get away from because some older technology does not play well with IPv6, but in as much as we can, everything runs on IPv6, which makes security analytics slightly more complicated because pretty much everybody gets IPv4 really well, but IPv6 has some personality characteristics, a lot more multicast. You have link local traffic, which is totally normal. But if you're used to seeing all traffic should be, within this tiny subnet, and you start seeing link local and you don't expect it, you might just panic. So you have to kind of smarten up your scan detection and host tracking mechanics to keep some of this in mind. And there's like a lot of other kind of corner case personality things with IPv6. It's pretty awesome, but it is a learning curve. In designing the security parts of the network, we had 4 basic design patterns that we use. 2 of them apply directly to the management net, and I think they're pretty important. It's like we control the design and operation, so we can move high-value activities through choke points to make sure that if you are seeing malicious, if someone is doing something on the management net, you can force that traffic through places where you're looking because it's your network. And then you decouple data gathering and analytics to provide like really good flexibility, because your attackers do not rest. And so you should develop an architecture which is fairly nimble so that you can change the way that you look at stuff really fast. So you decouple the gathering of the data from the analyzing of the data, and you can change then the way that you analyze stuff really fast. This is just a quick, busy slide about the architecture that you see. And I'm not going to wander through there, just kind of like you are here. Usually you're way up there as a user. It's where your data travels through. At each of these layers, there's there's security that's going on, whether it's authentication at the protocol level, at a user level, there's logging, there's some analytics. And so it gets fairly complicated, but it's also kind of fun because you can finally understand how the internet works. So the first service that I talked about was the Sinkhole service. And so I'm going to go through that in a little bit of detail, assuming I don't run out of time. Now it looks like I have 6 minutes. So, a sinkhole is just a way of using routing so that if a packet doesn't have a a better defined route for it to follow, it just ends up in the sinkhole. Use BGP for it. You can run it inside and outside the management net. The way we're doing it is we're running it passively. So it just goes to an analyzer and disappears. But that analyzer is running Zeek, and then we can use that to kind of do a signal to noise amplification, particularly on the inside. I can talk about that in a second. But it's a way of boosting the signal that attackers give you. And then if you're interested in it, you can drop a honey pot in there instead of just throwing it away, and suddenly everything is interactive, and you can gather non-radiation information. So externally, so this is like from outside ESnet, you've got the management net is the green blob. It's connected to the larger internet through the R1, which just says, hey, the management net's over here. And really what happens is all of the traffic destined out externally to the management net ends up in the sinkhole. And then you can analyze it, kind of look to see if there's unexpected behaviors or if people are doing some really hinky things. But in general, because you're not interacting, it's all passive. It's all basically kind of radiation patterns and stuff. So, but what this does is it allows you to, I looked at this as a better alternative to an ACL because it keeps everything externally looks totally normal. ACLs tend to be kind of fragile. And this way, if we make a mistake, if there are problems, if sites are supposed to be connecting and they can't, the data will end up in the sinkhole. And we can pick that up and use that as an alarm to go fix the network. Internally, the sinkhole is a lot more interesting because within the management net, you have normal communications. Each of the purple circles talks to the data center. They have their own routes that are, if you want to go here, take this route. But the sinkhole is just like, hey, the management net supernet is over here. So if you don't know where to go, just go to the sinkhole. So it acts like a network garbage can. And what that does is traffic without a specific route gets sent there. So if one of your systems within the management net gets compromised and they start scanning, that will just end up, everything will go to the sinkhole. And because the management net is a relatively quiet, well-defined, well-built place, you will not have a lot of noise or signal for that matter for any well-configured device. And so if you start scanning, it's going to be really loud, and that will allow detection to go pretty fast. As well, if something is misconfigured, or if someone adds a system and doesn't do something right, that will also end up in the sinkhole. And then we can use that to generate tickets to fix problems pretty rapidly. And so this is has both security as well as an engineering benefits. So we really like that. The last thing I'm going to talk about is kind of the pop back slide. So those purple circles, pops, that's just a point of presence. That's like a location in a data center. Where previously, if you remember the US map, there was a blue dot. This is what is inside of that blue dot. There is a router which just does the local network traffic handling, which is part of network engineering. We have a span port, so pretty much anything that runs through that router we get a copy of, which is extremely handy, because then we'll be able to see interactions between the out-of-band equipment, local compute infrastructure, and all of the optical gear. And so we can write specific policy to kind of model behaviors. And so unexpected behaviors will show up. As well, the router itself, like most routers, has ACLs all over it. Any traffic that fails an ACL gets forwarded to the Zeek instance as well, which allows us to do the same kind of signal to noise amplification, as well as doing problem detection. As I already mentioned, the entire management net's IPv6, which is high personality, and it's in 37 individual locations across the US. And
thank you so much,
all.
Scott. We are out of time and I have to move everybody on to their last break of the day. You get a 10-minute break, but I'm hoping Scott will hang around in chat and use the Q&A feature to answer the questions that have been left for him.